computer. So, all right. I'm Gregory Olson from the SEWN program. We are today talking with Aaron Baum of Baum Manufacturing, and this is another of our manufacturing series videos with small manufacturers talking about issues that our clients have faced and how they've addressed them and how they've overcome them. So first of all, good morning, Aaron. And
good morning.
We look forward to, can you tell us a little bit about Baum Precision and how it kind of evolved with you in it?
Okay, we started as a lot of small manufacturers did. My father started it literally in the barn. He was a machinist. So started in 1979. He worked at a large shop and decided that he thought he could do it better on his own. So he bought a couple machines, put it in the barn, and soon my uncle joined him, and they steadily grew over the years, slowly and steadily, and evolved from very manual type machines, you know, a couple of turning handles, mills and lathes, to mainly starting out doing building small custom machines for local manufacturers, production line kind of equipment, automation for them. This is before computers. And then as time went on and got into the late 80s, early 90s, computers became more available, and they started to transition to CNC work, and a lot of the those type of machine building projects literally went south to southern US and Mexico, and kind of evolved into mainly CNC machining. Mostly kind of fell into the niche of the aerospace, a niche in the aerospace market, and we grew steadily with that. I grew up in the business. Wasn't really interested much in the business as I grew up in it. You know, I thought it was probably like a lot of second generation doing the jobs nobody else wanted to do, or the punishment jobs that Dad was putting on me. And so I wasn't really interested in joining the business once I got old enough to go to college. But you know, always paid attention to it and watched the evolution from, you know, a very manual, rudimentary type of, you know, dirty, oily, smoky environment to, you know, more of a sophisticated knowledge work type of thing. And that became more interesting to me as I spent some time in a couple different careers. And then I came back after spending going to college, spending about 10 years doing other things in a couple other careers. I decided to join the family business again in 2005, and 17 years later, here I am. We successfully transitioned from the first to the second generation of first management and then ownership. So that's about
good.
How we got.
You know, can you kind of, your perspective when you came in and took over, and what was how did your view of automation change?
You know, I would have to say that my father and uncle, you know, they were both pretty on the, you know, as on the cutting edge as they could be for a small manufacturer. So I think at the time they were pretty advanced. Automation at that time was basically a CNC machine. Automation within one particular machining center. So they were doing some things back then that you know, were pretty innovative. They were doing lights out machining back then, not as much, not 24/7, but you know, they were able to automate through the tools that they had. But since I joined back to where we are now, the pace of progress and automation definitely has picked up. The requirement to be running 24/7 has definitely increased. The problem that's been around you know, pretty much my whole life of finding skilled machinists. So it's been a steady decline of that. That's only become worse. So, or more difficult to find that skill set. So, yeah, it became more imperative. I think it
Yeah.
became really obvious to me within the first couple years of joining back that this was really the only path forward.
You talked when we first started talking, you talked a little bit how your customers had driven you to a more um, integrating the automation with the supply chain. Can you talk a little bit about that?
Um, yeah, I have to apologize that maybe we can pause it for a second. That street sweeper is right outside my window again. I mean, can you rephrase that question or say that question again?
Well, yeah, I mean, when we first talked, your customers were kind of forcing you into the whole integration of machine to machine communication and all those kind of things, and so and how you responded to that.
Yeah, I guess if I look at the customers forcing us, I wouldn't say it was so much
Around
them.
machining and delivery of parts.
Yeah, I would say that you know, over the past few years, you know, with consolidation and I would say less knowledge on the from the customer standpoint about the machining process and more and them shifting more things onto us. I remember, you know, as a teenager doing a lot of this stuff, these parts for some of the same customers, we were responsible for a lot less. You know, they wanted to consolidate their supply base, not have so many suppliers, not have to deal with so much. They wanted to, you know, a complete component that they didn't have to process and they can just put it on their assembly line. So, you know, I think with the advent of supply chain management in the early 2000s and scorecards and those kinds of things, really became a two-dimensional scorecard, and it still is today. I think it's quality and delivery, and you know, we spend a lot of time, or have spent a lot of time. We're working. You know, we have gotten a lot better at being more efficient at it, but every week filling out these open order reports for customers to let them know the status of this or that, you know, and it's always a struggle being the small guy because, you know, they want, on one hand, they want to tell you, well, if there's a problem with the part, please let us know. You know, we need to know. And then you let them know, and then they panic and say they're not going to give you any more work. So we're always caught in that judgment call of how much information do you share, and when do you share it. You want to be transparent, but you also don't want to cause panic, especially in a customer that is not very familiar with the manufacturing process. All they're doing is managing a spreadsheet. You know, when is it due? How often are they late? What's their quality rating? Those kinds of things. So, you know, it's a challenge. And in our environment, especially in a job shop environment where, you know, we're not producing, you know, 1,000 or 1,000,000 widgets for, you know, a bracket for the Toyota Corolla. We're doing, you know, 50 of these, 100 of those, 10 of these, 5 of those. You know, everything has a different flow, and that's a real, you know, in studying, you know, manufacturing, you know, those kinds of things. You know, that is the most complex manufacturing environment. And as small manufacturers start to grow, that problem becomes exponential. You know, it's sort of something that a 2 or 3 man shop can, you know, the owner or the boss can keep most of that in his head. But once you get beyond 5 or 6 or 7 machine centers and, you know, several suppliers and parts everywhere, it becomes a hot mess of trying to keep track of all that. And you know, any scholar of, you know, scheduling and MRP systems and those things will tell you that is the most complex environment. And that is most often where most of the small businesses are.
Right.
Managing this schedule that's more complex than any of our customers or
Yeah.
at least as complex as our customers, but they have teams of project managers and, all that kind of, lots of resources to throw at it, where in most of our cases, we're wearing 5 or 6 different hats and very little time to pay attention to it. So the integrity of the information, it just is super important. And what I've come to realize is that, all of the workers, all of our employees, they want to do a great job, right? But there's tremendous variability in information and in the way one person does something to the next. So if you're relying on a person or each of your people to record the same information the same way at the same approximate time, all while they're working on different parts that take different times and have different anomalies to them, it's really difficult. So what it forced us to do, and we're still not there, I don't know if we'll ever be there, but we're getting down the road of taking advantage of the technology that's there. We have this data rich environment. We have data everywhere. The controls on the newer machines have the ability to monitor pretty much everything that's going on within them, So we have this amazing ocean of data. It's just a matter of, okay, what can we get out of there that gives us good information to be able to record, put into, schedule in an automated way, and be able to give the feedback to the customer in a non-emotional way, in a transparent way. Say, this is where it's at. Again, we have a long way to go to get to that that place, but it is that's where it's forcing us. Long story short, that's a good question, and one that I could probably speak a couple hours on, because of just the tremendous complexity and the hours and hours and hours that I've spent, my managers have spent, just kind of running around gathering information. Where is this? What's that? What's the problem with this? And then trying to consolidate it to give to a large customer, either a first or second tier aerospace and defense contractor, in a way that doesn't freak them out and say, oh, we can't deal with small business, with these small shops, because they can't get their stuff together, and they don't have the time or compassion to think about all the stuff that we're dealing with. They just want their parts, and they want them right.
Yeah, exactly.
And they don't always want to hear about, XYZ with that particular part. So it's a real challenge, I guess, the communication of status of where things are at.
You talked about, you said your MRP, you actually had to do some in-house redesign of the MRP system.
Well, yeah, we had when I say MRP or ERP,
right,
had a system for a long time. It's probably for the longest time, and probably still today, was the market leader, had the largest market share. Very, very simple. It was a computer system. Everything was on the computer, but also relied on a piece of paper as well to kind of track things. And it became apparent to me, going through some of the lean stuff, lean exercises, that the amount of time and waste spent running around looking for the traveler or the job folder, it just was not efficient. And the information was not where it needed to be, which is right in front of the person doing whatever that operation on that particular part was. It needs to be right there, right accessible immediately. Otherwise, what you're faced with then is relying on institutional knowledge. And that guy that's been here for 18 years and has done that part 19 times over, and it's right here. Well, that's the problem, and I think the aerospace industry has recognized it. They kind of talked about it in their latest revision of the AS 9100 standard, but so somebody on that committee understood what was going on. I don't know that all the auditors really understand what they were getting at there, but at least that's what it resonated with me. We have a long, especially in the aerospace and defense industry, you have a lot of shops that have been around a long time, aging workforces, a lot of institutional knowledge of guys that have been tremendous machinists, craftsmen, great guys, but there's always that big gap between, what's in people's head that they've been trained well and been at this job for 4 years to now, how do you sustain that to pass it on to the next guy, or how do you scale that? And as consolidations happened, less machine shops out there, it's a big problem, right? So how do we capture all that, as much of that institutional knowledge as we can, and not rely so much on that superstar?
Mhm.
We all want superstars, but it's not sustainable.
Right.
So how can we gather that knowledge and have it in front of the person actually doing the work? So we decided to shift to a whole newer system, which is like anything, any change of an ERP system is. I've watched customers do it and said, "Oh, I don't ever want to do that," and I probably waited longer than I should have. But it became to a point where I just, we have to do it because, it just was taking too much time to gather the information, to have real-time visibility. We're getting better now that we're implementing the new system. But even with that brand new system that was developed relatively recently, there's still gaps in it. So, we have a system that we can monitor everything that's going on with the machines. I know, what machines are running. I could look on my phone right now and see what machines are running, the status, if there's any alarms. You can be inundated with data. My phone could be, pinging me all night long when things happen. But we have to filter that into usable information that we can, as the leaders, we can make decisions that
Mhm.
make sense. And it's always managing and especially for us, for small guys, it's always managing the bottlenecks. Where is the bottleneck, and predicting that. And I think without that real-time information, if you can get the real-time information out of the machines, what just happened in the last 24 hours, and how does that impact your schedule going forward, that's the key. We're not there yet. We're getting there, and we're a lot better than we were, but we wouldn't have that without automated data collection. And the gap, though, is between the scheduling system and the real-time information. How do we make that happen automatically? And that is some of the some of the things we're working on.
Right, because that's an industry-wide issue, I'm sure. And I
Yeah.
think you guys are much farther ahead than a lot of other people. So kudos to you. Can you talk a little bit, Aaron, about the smart machines? I mean, that you've been working on doing that and making your machines smarter, I guess.
Yeah, I think it's through just a lot of that data collection is, there's so much information that's being collected in the controls, especially of the newer machines, data around, the temperature, alarm status, tooling management, things like that, you can proactively make decisions. So we're doing things like, proactively managing a tool, knowing not waiting for it to get dull or produce a bad part, but saying, okay, we know based on, the material it's cutting and the manufacturer's data, their recommendations, how long this is going to survive for. So cutting that a little short and being proactive. And some of our newer machines, we have invested heavily into machines that have a lot of tools capacity, so that we could have redundant tools. So we know that it's You know, we know that that tool is going to wear out somewhere along the way, or it's going to get to a point where it might wear out. And that's the thing,
Yeah.
where it might wear out. And that's where, you know, you kind of get into that preventive maintenance of, you know, predicting the failure modes and not letting them happen, not letting the tool break, or not letting, so that's probably the biggest thing we have implemented so far.
Mhm.
There's a lot of other predictive maintenance that can be done through just the monitoring, knowing how, you know, how long a machine's been running, temperatures, heats, alarms, things like that, that just will help us, you know, keep that capacity and those our run times. So basically, one of the things that I look at constantly, and we review every week with our employees, is what was our uptime of the machines? How much out of the last 24/7 were those machines running? Because we're making heavy investments in those things based upon, you know, 140 to 150 hours of, you know, up and running machines. The problem that introduces, that we didn't have before, we had 8 to maybe 12, 16 hours of machine runtime in the past, but now we have 20, 24 hours. Well, you're using a lot more, you know, you're using that machine a lot more within a week than you were before. So things wear out faster. Things need to be changed out more frequently just because of the amount of time you're actually using it. So, so yeah, those are some of the things, you know, I'd say around maintenance is probably what we're noticing the most. That's the lowest hanging fruit to start with. And then there's a lot of, there's just so much possibility with all the information that's there. It's a matter of making your best choices of what you do with all this data, and making decisions about how you can improve your process.
When Denise and I came in and met with you, and we were talking about technology road mapping,
Mm-hmm.
and you have had you have looked at a lot, and you have done a lot in that whole concept. So can you talk about the approach you take to technology road mapping?
Well, let's see. The roadmap seems to, well, like any trip, you know, you're going to make some shifts and turns along the way as things happen, and as business changes. You know, it's about adapting to what the problem is in front of you, I think, and what you have available. So, you know, it's you know, we have these big problems that we're trying to solve. I think, as I was describing before, kind of that automated information gathering of, you know, what just happened and how can we get that right into the schedule without human intervention, so we have good transparency. You know, I think that's kind of what I like to call the Holy Grail project, and we'll get there someday. But there's, you know, the low-hanging fruits along the way that we can start to take advantage of in real time. So that's kind of, I guess, the approach, right? What is the ultimate problem we're trying to solve, which is, you know, having a predictable schedule and lead time. I mean, the customers, you know, the very simple questions that they ask us, which was the most difficult to answer, is, you know, what is your lead time, and what is your capacity? Well, you know, I don't believe that many small shops have a real good grasp on that. It's more of a feeling. Yeah. So how can how can we get there? That's a very complicated question to answer. You know, and the answer really is, well, it depends. You know, and it really does. So that's the ultimate. The ultimate goal to me would be, okay, well, let me just pull this up and say, okay, right now, if you place an order within the next, you know, 4 hours, this was your lead time. But the matter of fact is, your lead time and your capacity is going to be ever changing from day to day in this job shop environment. And, the difficult questions are always, they want a simple answer. Can you guarantee that? Can you
Yeah.
guarantee? Well,
Yeah, I
I
agree.
can guarantee that if I get, if I put a manager on it and hound that project through. But anybody that's been in this business for a long time will tell you that wears on you, and there's only so long that you can do that, and
Yeah.
it's not a sustainable process. So how do we make some sense out of this? So that's the bigger problem. And then as we go down that road of getting to that real-time information that doesn't require so much human intervention and interpretation, what other things can we take advantage of? Like the predictive maintenance stuff, I think, is a very low-hanging fruit. Tool management, predictive maintenance, and there's, and then there's future steps beyond that. Automation, that was really, in my opinion, the first low-hanging fruit, right? Like I said, my dad was doing it before I came back to the business, with the tools we had available, and then then that just evolved from what's available on the market. In my opinion, it's the machinery and technology that's available. We don't own any of that technology. We buy it to utilize it, but it's not our patents and our technology. We're programming things the way we do it, and we have our secret sauce, more or less, but we're kind of using what's available out there. So I think what will give competitive advantage in the future is, how can we gather, how can we use the information that's available to us in a better way than the next guy, or that will give us lower cost, higher efficiency, all those things that we're always in the quest to to get to. So it's a convoluted answer, but I think
No, it's not. That's great.
I
I think
start with the big picture in mind, and then what low hanging fruits can you pick along the way that make it practical? Because the difficulty of being a small business is, I don't have a team of programmers and engineers or whatever to throw on this problem, for a year or two to solve it. We have to kind of figure it along the way. But and then if that technology is available, from a vendor, from a supplier, is it going to be affordable? I mean, that what I'm speaking of, I'm sure, there are big ERP systems, MRP systems that do what I'm talking about, but not available to the little guy for a feasible price. So I think that's, to me, that's where I see things, is that we have to make these tools available, and to small business, that we can make these have this real-time data collection, and not just data collection, because we all have that. It's just, how do we put it in a way that makes sense, that we can manage our business? That's the bigger problem.
Now, if you talked about it, and you really do that, if you could just kind of sum up a little bit, a recommendation or two to a small manufacturer looking at advanced technology, what should they focus on? What should they look at?
Well, I mean, I think first off, if you're not thinking about automation in a way, when I say automation, people automatically think assembly line, robots. Figuring out how can you keep that machine running without a person standing in front of it, whether that's robotics, whether it's multiple pallet, lots of tools, so you can run be flexible. So I think we're in the cool thing about where we're at today is that you can basically automate a low volume, high mix type environment, which is where most of us are, and minimize the downtime of a spindle. I think one of the most important things, or a spindle, or whatever the working unit of your manufacturing process is, you know, the advantage it has is that you could get a lot more accomplished with less square footage of building and people. So that's the first thing. You know, you really have to, if you are relying on manual equipment or a machine that requires somebody to be standing in front of that at all times, if you're not doing that, I believe you're setting yourself up for real trouble, because you know, that's just people are not a commodity that we have, and I think business knows that. It's difficult to even find somebody without any experience to come and walk in a shop, let alone somebody with experience. So that is a major problem. And so that's number one. And then number two is, again, how do you start to, I think it all focuses around people. How do you start to capture your, you know, your institutional knowledge, or the secret sauce of what you do, and put it and systematize it, if that's a word. You know, make things into systems in a way that's practical. Because, you know, when you say that to somebody, it's, you know, your eyes start to haze over. Oh, you're gonna make a system. You're gonna have a book with a, you know, a binder with procedures and things like that. And you know, that's really no good either. You know, binder with a paper procedure, and it might be good to show a customer or an auditor, yeah, we have this, but what really needs to happen is that process or procedure needs to be integrated and put at the point at which, you know, you're able to find somebody, young person or whoever, you know, somebody changing careers that wants to come and try out manufacturing, and put it in front of them, and be able to train them in a consistent way. This is our process. This is what needs to be done to at this, you know, in your job. So that's I think number two. And I think a system that you know, it has to be on the computer. You know, it's become so cheap with the information of displays. You know, I couldn't have imagined 10, 15 years ago of having, you know, large screens in front of every operator at every machine. So, you know, we had to have the big prints and the job folder, you know, but you got to use technology that, you know, in a way that, you know, is not going to break the bank. And the good thing about the way technology is going is it's ever becoming cheaper.
Yeah.
A 27-inch display, you know, 15 years ago would have been ridiculous. Now it's $120 or something like that. You know, and, you know, that information, the communication between, you know, your team, the engineer, you know, the programmer, or the machinist, or the people in deburring, or the people, you know, in shipping, you know, can happen without them making a step. So I think that's number two. I think it's, first, automate what you can. Second, or maybe in tandem, is you got to get your system to a spot where the information needed to do their job, do a quality job, it's out of your head and onto a system where it's accessible to the, you know, the person that's doing that piece of direct labor, because you can't control everything, and that's the best way in my opinion.
That's great. Thank you, Aaron. I appreciate it. And thank you for your time today, and for your insights on this process, particularly around the software in the system. And we will wrap this up for today. So let me stop the recording.